Hello Titans, this is Mr. Simpson, and tonight I'm going to be working through the first 37, 38 problems from your final review that's posted online. So if you'd like to have that out and follow along, I won't do every problem, but I'll at least do one of each type. So first of all, when we have rational exponents, remember the flower power where the denominator of this is the root and the base, and then that's all raised to the second power. So now we take the cube root of 64. So what number times itself gives me 64. When I multiply it 3 times is 4. And then 4 to the second is 16. So your answer should be 16. Number 2, remember when we're dealing with negative exponents, the first thing we have to do is get rid of the negative exponent. So I rewrite it as 1 over 5 to the positive third. And now we're asked to evaluate. So then 5 to the third is 125. So my answer is 1 over 125. And number 3 here is the cube root of a negative 8. Now remember, we can take the cube root of negative numbers. If the index was even, then it was negative, it'd be no solution. But we can do the cube root of a negative number because negative 2 times negative 2 times negative 2 equals a negative 8. So the cube root of a negative 8 is a negative 2. Alright, so continuing with exponents here, again, we can't ever have a negative exponent, so I'm just going to rewrite that as 1 over n to the positive fourth, and now that's in simplest form. Remember, anything to the 0 power is equal to just the number 1. Here we have the 2, which again, remember, everything's being multiplied here, so it's 2 times x to the negative first times y to the negative second. So the 2 is going to stay in the numerator, but then again, remember, the crying babies, we got to make them happy, so we're going to move them, and we can change the sign to a positive. So both of those go to the basement. And our answer is 2 all over x y to the second. And number 7 here, again the 3 is going to stay. The x to the negative fourth must be moved down to make it x to the positive fourth. And then anything to the 0 power is 1. So now my final answer is 3 over x to the fourth. Again, a few more things with positive and negative exponents. So here we're using the product property because we have the same base. So remember, if the base is the same and we're multiplying, we add the exponent. So 4 plus negative 2 be positive 2, and that's a positive exponent, so my answer is n squared. Here, again, we have the same base. So I keep the base the same. I add my exponents. 2 plus negative 3 is a negative 1. But I'm not allowed to have a negative exponent, so I must rewrite it as 1 over m to the first, or just 1 over m. Here we have the power of a quotient. So when we have a power of a quotient, we have to distribute the power to every factor inside. So we have 2 to the second, b to the fourth to the second, all over 3 to the second. So then what's going to happen here is we get 4b to the eighth, because remember, when you have power to power, we have to multiply those, all over 9. So there's my final answer. And on this next one, again, we have to take the 4 and distribute to each one. So n to the third to the fourth, power to power, we multiply, so that's n to the 12th. Then we have 2 to the fourth. Well, 2 to the fourth is 2 times 2 is 4 times 2 is 8 times another 2 would be 16. So my final answer is n to the 12th all over 16. Alright, here they ask to evaluate. So this is an exponential function. So we want to evaluate this when x equals 3. Remember, that just means f of 3 is equal to 2 times 5 to the third power. So based on order of operations, we do 5 to the third, and that's 125. Then we have to take that times 2. So my answer is 250. So here we're plugging in for number 13, you'd plug x in to be 4, and then evaluate it. Remember, do the exponent first, and then the multiplication. here we're dealing with growth and decay. So remember, this is the part we're concerned about. This is the exponential part. And so since this is 0.9, which that's less than 1, then that represents decay. But the rate that it's decaying is how many cents is this below a dollar? Well, if that's 0.90, that's 90 cents. That's 10% or 10 cents below. So it's decaying at a rate of 10%. So in this problem, we're looking at this. This is greater than a dollar. So that is a growth. So, and the rate of growth would be 5 cents over the dollar, or 5% rate of growth. Alright, not going to do both of these. I'll just do one of them. They're both the same type. Remember, we're dealing with exponential equations. If they have the same base, then that means the exponents have to be equal to each other. So we just set the exponents equal to each other, and then we solve this multi-step equation. So I'm first going to get the x's to one side. So I have 2x plus 5 is equal to a negative 7. Subtract the 5 from each side. I get 2x is equal to a negative 12. Now I'm going to divide by 2. I get x equals a negative 6. Now you can go ahead and do 17 by following those same steps. Number 18. Alright, the nth term of a given arithmetic sequence. So again, remember that you have your first term, so the a-nth is equal to a sub 1 times r to the n minus 1, and r is your rate of change. So we have our a-nth term is going to equal 4, and then the rate in which we're doing this, well, if we divide, we take 24 divided by 4, that's equal to 6. 144 divided by 24 is also equal to 6. So my r, my constant ratio, is 6 to the n minus 1. So sometimes it might be written like this, but there's your a-nth term. So try to follow that in number 19. Again, notice the first term goes here, and then the quotient, the common ratio, I take like the second term divided by the first term, or the third term divided by the second term, to figure out what my common ratio is. And that's just to the n minus 1. And if I try this, if I want to find the second term, I plug 2 in for n. 2 minus 1 is 1. 6 to the first is 6. 6 times 4 is 24. So it checks. Simplify each expression. So now we're moving into the next chapter. And here we're adding polynomials. So remember, when we add polynomials, we add like terms. So my like terms, I always want to write them in descending order. So I have the ones that have the same variable raised to the same exponent. So negative 6 plus 1 would be negative 5, x to the second. Then I have x plus 2x, because these are like terms, would be 8x. And then 4 plus 5 would be plus 9. And there's my final answer. So follow that for number 21. In 22, we're subtracting. Remember, we like to keep, change, change. So 2 plus 2x squared, okay, plus, and now I'm going to change, negative 1 minus 2x minus x squared. Notice how every sign changed. And now I just add. So I have my highest powered term. So 2x squared minus x squared would be x squared. Then I have just no other x terms, so that's just negative 2x. Then I have 2 plus negative 1 would be plus 1. And there's your final answer. So again, follow that to try to do number 23. Alright, now we're multiplying binomials. So remember, we could do FOIL, or we will do the box method, which is what we tended to do the most. So we go 6k minus 4 and k minus 3. So again, 6k times k is 6k squared. K times negative 4 is negative 4k. Negative 3 times 6 is negative 18k. And negative 3 times negative 4 is a positive 12. And now we combine our like terms. So we have 6k squared minus 22k plus 12. So again, follow that same steps to do number 25. Alright, now we're asked to factor. Well, in this case, we're just factoring out the common factors. So I look to see what's common in these two terms. So I notice that in 7 and 56, 7 is common, and they both have a variable n. And now when I divide that out of each of those terms, that's what goes on the inside of the parentheses. So 7n squared divided by 7n is n, and 56n divided by 7n is 8. And then there's your factored form using the GCF. So again, do that for number 27. Here we're asked to factor completely. This is just a quadratic trinomial. Again, this is just where we'd use the x method before. We put negative 18 on top, negative 7 down below. We have negative 9 and a positive 2. These multiply to give me a negative 18 and add to give me a negative 7. So it's x minus 9 times x plus 2. So again, follow that step for 29. Here we have to use the x box method. So we have to multiply the 9 and the negative 2, which is a negative 18, to get the negative 3. So what factors of a negative 18 add up to a negative 3 are negative 6 and positive 3. So now we have to put that in the box. So remember, we have 9x squared, we have negative 2 here, and we're going to go negative 6x and 3x. So now we try to find the GCF of this row, which would be 3x. So 3x times what gives me 9x squared is 3x. And 3x times what gives me negative 2x is negative 2. And then 3x times 1 gives me my 3x. So my answer is 3x plus 1 times 3x minus 2. So again, you follow those same steps to do number 31. Alright, here we're factoring. These are specials. This is a difference of two squares. Remember, we called it dots. Difference of two squares. Because again, for the middle term to not happen, one has to be a plus, the other has to be a minus, and these are perfect squares. So 5x and 5x gives me 25x squared. 2 and 2 gives me my negative 4. And again, the middle terms cancel out. And then we have the perfect square trinomial here. So this is a binomial that will end up being squared. Square root of 81x squared is 9x. Square root of 16 is 4. And then whatever the sign is in the middle is a sign that goes here. And there's our answer. And remember how we checked it. We take 9 times 4 is 36 times 2, and that had to be 72. So 34 and 35 are very similar, so just follow those examples to complete those. And the last ones that we'll go through for these two chapters. Here we're asked to find the zeros. So remember, to find the zeros is, if I set this equal to 0, what values of x will make this equal to 0? Well, based on the zero product property, any factor that contains the variable x can be set equal to 0. So x minus 6 equals 0, x minus 5 is equal to 0. So my answers are x is equal to 6 and x is equal to 5. And those are the two values of x that make this 0. Remember, we can't set the numerical value of 3 equal to 0. So those are my answers. So follow that example for number 37. All right. That takes you through the first couple chapters of the review. Again, hopefully you have this with you in class on Friday. You're able to look at this and fast forward and see what you need to do for that worksheet, but also with the problems that you're working at home as you review for your semester final. So we'll try to get another one put together for the second half of the review. Good job, Titans, and we'll see you later.